So here we are. I hope everyone appreciates the little GIF wrap that I have here. I don't know if it's GIF or GIF, but I guess it could be GIF. We're going to wrap up polynomial division. We've had 2 days worth of notes on this material. One more time, we'll probably take a look at long division. But we're going to answer 5 questions. When can I use synthetic division? When do I use placeholders? And when I do, how many of them do I need? When I divide, how should I write my answer? What's the difference between finding P of A and dividing P of X by X minus A? And what will we be using this stuff for? So in the next 40 minutes or so, we will be addressing and answering all of these questions. And I will not be singing, "It's peanut butter jelly time." Where you at? Where you at? Where you at? Where you at? Now there you go. There you go. There you go. There you go. Okay. So synthetic division. Remember, you can use this when the divisor is, anybody remember it? It's linear and it has a coefficient of, when it's linear and x's coefficient is 1. You can use it when the divisor is linear and the coefficient's not 1, but there's 2 other steps that are kind of cumbersome enough that I wouldn't recommend it. So the divisor's got to be 1 and x's coefficient, the divisor's got to be linear and x's coefficient's got to be 1. So what I'm saying is if you're dividing by x minus 2, then you can. If you're dividing by 2x plus 6, or plus 7, we'll say, you can, but you shouldn't, okay? You can, but you shouldn't. If you're dividing by x squared minus 2, then you shouldn't, okay? And you can't, actually. With the 2x plus 7, it's weird. What you would put in the box is negative 7 halves. But then when you get your quotient, you'd have to put a 2 out front to make everything match up. Because, just because of the nature of the beast. So you'd have to, in your quotient, you'd have to throw a 2 out front. So, like I said, and because of that, it's kind of weird. And then you end up with fractions and, yeah. It kind of reminds me of, if you do that, it reminds me of deep fried bananas. I love bananas. I love deep fried stuff. So you'd think it's pretty good, right? Well, I've got news for you. Deep fried bananas, well, I won't say how it made me feel, but I'll just say I didn't like it. Didn't like it. Okay. We doing okay so far? Well, we've got one question of the 5 down. Here's number 2. When do I use them and how many placeholders do I need? If you've done the Math Excel homework, you'll recall that there's one problem like this. X to the 5th minus 32 divided by x minus 2. So when you went to set this one up, some of you might have rage quit and not done this one because you couldn't figure it out. Well, first of all, what goes in a box here? We put a 2 in the box, good, and then we leave some space and then we leave our line. And some people were trying this. They were saying 1 and negative 32. Well, I've got news for you. That is not going to get it done. Remember, with synthetic division, what's going on is all you're using is coefficients. So that 1 is x to the 5th's coefficient. So up next ought to be x to the 4th's coefficient, and after that ought to be x to the cube's coefficient, and after that ought to be x squared's coefficient, and then x's coefficient, and then the constant. So if we look at it that way, we'll realize quickly that negative 32's got to go way down the line, doesn't it? That negative 32 is our constant. It's our number. Hey, wait, didn't we just learn that in 5.1? Constant and linear and quadratic and quartic. So everything is everything that we talked about 2 weeks ago is coming back. So as far as placeholders go, what do I use for a placeholder? A 0. Nice, good. Yeah, because the term doesn't exist, I've got to use 0 for the placeholder. Excellent. So So I'm going to have a 0 for the x to the fourth. I'm going to have a 0 for the x to the cubed, and a 0 for the x to the squared, and a 0 for the x. Okay? So it makes these rather boring when you multiply one like this out, doesn't it? How do you explain what word-wise? The question is, how do you explain that word-wise? To answer the question, okay. So to answer this question, how do I use them, and how many, or when do I use them, and how many placeholders do I need? So here's the deal. For a divisor, for a dividend in standard term, for a dividend in standard form, in standard form, use zero, use the number 0 as a placeholder for each absent term. And what I mean when I say each absent term, if we're missing a quadratic. So for instance, if we have x cubed plus 2x plus 1. In this case, our absent term is for the quadratic. Okay? We're missing a quadratic. So for that quadratic term, we would need 0 as a placeholder. So that would be the best way I could think of to put it in words. Right. Yeah. You're welcome. So for a dividend in standard form, use 0 as a placeholder for each absent term. Okay? So if we had to divide this one, I think in the context of the homework, didn't this say, is that a factor? Isn't that what it said? Something like that. So finishing this, then we take the 1 and we drop it like it's hot, and we get 1 and 2 and 2 and 4 and 4 and 8 and 8 and 16 and 16 and 32 and 0. So we ended up seeing that, yes, x minus 2 is a factor. Okay. Wow. So you might think to yourself, well, wait a minute, 5.3 was last week, and 5.3 is done and gone, and I don't need 5.3 anymore. Well, I've got news for you. When we answer the question about what will we be using this for, you'll see why you need to be good at 5.3. You'll see why you need to factor, which we covered in chapter 4, section 3 and 4. Okay? So we're almost ready for that. We got one more question to answer before we get to that. What's the difference between finding P of A and dividing P of x by x minus A? Anybody got this one? Yeah. Yeah, you don't switch the sign here. When you're finding P of A, put A in the box. So what I'm saying here is when they give you a number, you put the number in the box. So a specific example, f of x is 2x to the 7th minus 4x to the 5th plus 7x squared minus 4. Okay? Find f of 9. That's a 9. Sometimes my 9s and a's look alike. So if they ask you to do that, what that means is in this box, we don't have to switch the sign. We're finding the value of the function when x is 9. The number is 9, so we're just going to put 9 in the box. And then 2. And then let's go ahead and set this up the rest of the way. What would we need after the 2? Not a 1. There's a 6th degree term missing, so we need a 0 for the 6th degree term, and then negative 4 for the quintic term, and then what? 0 for the quartic term, and then 0 for the cubic term. Nice. And then 7, and then after the 7 would be a 0 for the linear term that's absent, and then a negative 4. So then when we do this, what is f of 9? Or where is f of 9 going to be, I should say? It's going to be what we normally see as the remainder. Okay? So when you do a problem like this, the answer ends up being that very last entry in that spot right there. Okay. Should we run through that just to verify that? Here we go. So we're going to take the 2 and drop it, and we get 2 times 9 is 18, and 18 plus 0 is 18, and 9 times 18, people want to get out calculators. You don't need a calculator for this. 9 times 10, I said 9 times 10 plus 8, that's 90 and 72. That's 162. And then that's going to be 158. And 158 times 10 minus 1, I said times 10. I keep writing my 10's weird. So that's 1580 minus 158. So that's 1422. 1422. This is going to be a big number, isn't it? Should we keep going, or are we good? I'm here, and let's keep going. I'm here, and we're good. We could keep going. So 1422 times 9, 1422 times 10. Hey, I wrote 10 finally the right way once. So that's 14220 minus 1422. All right, I'm going to cheat. I'm finally breaking down. I'm cheating. Mark this day on the calendar. Mr. Minnick's using a calculator now. Okay. Let's verify that 18 times 9. I'm pretty sure I did that right. Yeah, that's 162. So 9 times 1422 is 12,798. 12,798. 12,798 times 9 is 11,500, 182. 11,500, 182. Plus 7 is 11,500, 189. 11,500, 189 times 9 is 103,6701. 103,6701. 103,6701 times 9 is 933,0309. 933,0309. 933,0309 minus 4 is 933,0305. And that's our answer, 933,0305. Wow. 3 weeks later. So let's see how we did. 9 is my x value. 9 is my x value, so I want to evaluate this function. So I want 2x to the 7th minus 4x to the 5th plus 7x to the squared minus 4. 933,0305. There it is. Okay? Everybody see how that works? Oh, the question is, how do I take 9 and store it in my calculator as x? When I go shopping on the west side, I go to the stow. And on the TI calculator, the stow button is right above on. So you put the number in, and then you press the stow button. Yeah, it's kind of like hitting the crate button. Okay. So the point here, coming back to this original question, is finding P of A. Really what you're doing in finding P of A, this is the process of synthetic substitution. That's the process of synthetic substitution. So with that, what you're doing is you're just putting A in the box, okay? A in the box. Whereas this other procedure, when you divide, this is synthetic division. And it's interesting, synthetic division and synthetic substitution, they're the same thing. They're the same thing. The only difference is how you approach what you put in the box and what you do with the answer, what you do with the stuff on the bottom row. So synthetic division, here's where you switch the sign when you put that thing in the box. So really the procedures are the same. You're doing the same thing, but you're doing different stuff with it. It's kind of like cows pooping. Let's think about this for a minute. When cows poop, you might think that's really gross. And you might say, I'm not touching that. But farmers, they take cow poop and they shovel it up and they pile it up, and they put it in these big storage tanks, and then they add water to it, and then they add the cal P to it. And it's great. They have this big liquid tank, and it gets like this 5-foot thick crust on the top of it. And you might think, well, I better not walk on that, because if I fall in, I'm literally a goner, more ways than one. So you don't want to walk on it. But anyways, then they pump that out into their tanks, and then they go spread it in their field. And you know what? It helps the corn grow. And knee-high by the fourth, and next thing you know, they got the best crops out there. So it's kind of the same thing here. It's cow poop. Cow poop ends up helping corn grow, right? Synthetic division either tells you what the value of a function is for a number, or it can tell you how a polynomial breaks down. Okay? Why do you always got to talk about gross stuff, Mr. Minnick? That's nasty. Well, speaking of gross stuff, this is what you're going to be doing next. And they kind of ease you into this instead of throwing you under the bus, to use a metaphor. They say, okay, hotshot, here's this cubic polynomial that can't factor. Here's this cubic polynomial that can't factor. And what we want you to do is we want you to find all the zeros without a calculator, without Mathway, without looking at Nate Emmons' paper, without looking at somebody else's paper, without punching in the TI Inspire, find the complex zeros of this polynomial, because you can do that, and I'll show you how to later this week or next week. So what are the zeros of this? Well, we might know how many there's supposed to be. I think we know, even though we won't officially study this till 5.7, how many zeros are there supposed to be? Since it's cubic, how many zeros are there supposed to be? There's supposed to be 3. Good. Now, you know what they're telling us? They're telling us x plus 5 is a factor. They're telling us x plus 5 is a factor. What you need to realize, and this is going to be 5, that tells you 2 things, and it tells you to do something else. It tells you 2 things, and it tells you something else. Because x plus 5 is a factor, since x plus 5 is a factor, comma, what is a zero? -5. Everybody all right so far? Now this next thing, some of you might have seen this, and for the rest of you, this might blow your mind. This is so profound right here. It's so simple, yet it's so profound. So it tells us that -5 is a zero, and when we divide, x cubed plus 9x squared plus 23x plus 15 by x plus 5, when we divide that by that, what's going to happen? We talked about this a couple days ago. We said if something's a factor, then what? Or if... Yes, the remainder is going to be 0. Nice, good. The remainder will be 0. Now just bear with me for a second. So I'm going to go ahead and cut this out and put it on a new page. And hopefully you'll see the connection between evaluating a function, between a 0, between the remainder being 0, and all this. It's so cool once you kind of get this connection. So let's think about what it means to be a 0. It means that's the y value, or that's the value of the function when you evaluate it for a certain number, for a certain x value. So watch what happens here. Synthetic division and synthetic substitution are really the same thing. So what am I going to put in that box? What am I going to put in the box? -5, good. So a couple minutes ago I said that factor that's given tells you 2 things, and it tells you to do something else. It tells you, first of all, that -5 is a 0. Second, it tells you that the remainder will be 0. And the third thing it tells you is, you know what? You better go divide. Bless you. So here we're going to synthetically divide. So we got a 1 and a 9 and a 23 and a 15. Okay. So we're expecting 0 to be a remainder. So let's see. We got a 1 and a -5 and a 4 and a -20 and a 3 and a -15 and a 0 remainder. So this is kind of weird because it really says f of -5 is 0. Since it's a factor, we expected that all along, but evaluating the function, getting 0 for a remainder means that it's a 0. And that's a big deal. That's a huge deal. Getting 0 for a remainder means that's a factor. It also means that the number you put in the box is a 0. So I can't stress this enough. To try to make this as clear as I can, what marker should I use? What creative pen? The smiley faces? I'll try. So if, well, those aren't going to show up. Let's try that thickness with the smiley face. If, there we go. If, really? That's how you're going to be today. That's how you're going to be today. Make it a little thicker with that one. If, can you read that? If the, no, that's not going to work. It's pretty, but it's not going to work. If the remainder, I'm going to abbreviate. Everybody get that means remainder? If the remainder is 0, comma, then the number, N-O dot, that's number, then the number in the box is 0. If the remainder is 0, then the number in the box, the number that you would put in the box, is a 0. If the remainder is 0, then the number in the box is a 0. If the remainder is 0, then the number in the box is a 0. And the factor would be x, and then either plus or minus that number, and it's counterintuitive. Remember the nature between a 0 and a factor? All that stuff's coming back, and it's all going to fit together quite nicely. Doing all right so far? We're almost done here. So again, if the remainder is 0, then the number that you put in the box is a 0. Okay. So when we synthetically divided, what's our quotient then? Our quotient is, the quotient's not x plus 5. X plus 5 is they told us it's a factor, which tells us the remainder is going to be 0. Tells us that -5 is a 0. But what else does it say? Well, what's our quotient, first of all? We just did this yesterday and we forgot how. Thank you. X squared plus 4x plus 3. Okay? So rewriting all this stuff is cumbersome, and you don't have to rewrite it, but I want you to be aware of is this. The original function, x cubed plus 9x squared plus 23x plus 15 can be rewritten as the product of its factors. Can be rewritten as the product of its factors. Okay? And that's what they were trying to have you do in that one exercise on the Math Excel homework, the one where they would give you a factor and you had to factor it and write out more factors. So what they want you to do next then is factor this. Factor this. So back to 5.3, that's what you were doing in 5.3. You were factoring, and if you can't factor moving ahead, then you're not going to be able to do what we're doing. That's why 5.3 is so important. That's why we had it. That's why we spent 6 weeks on chapter 4 talking about foiling and factoring. So what's that factor into then? It's going to factor into what? X plus something and x plus something? Plus 3 plus 1. There we go. Oh, plus 3 plus 1. Let me change that. X plus 3, X plus 1. So let's look at this all on the same page, and let's go back and answer the question then. So, because of all that, what are our other two zeros then? Be careful here with the other zeros. -3 and -1. So my question is, what? Oh, I guess I could just kind of answer this. X plus 3 also is a factor, right? So if we had synthetically divided and put a -3 in the box, that would have worked. If we had put a -1 in the box, that would have worked too. Everybody kind of see that? So guessing and checking, we'll see in a couple sections how to not have to guess and check so much. But yeah, you kind of guess and check. So if you had put a -3 in the box, you would have got a 0 remainder. And then whatever quadratic would have remained could have been factored again. Okay? And we would have ended up getting the same zeros. Yeah. Everybody kind of get that idea? Okay. So you ready for the next step then? Where we're going to be taking this? At the end of next week? Here's a sneak peek at the end of next week. What's going to happen then? They're going to say, okay, hotshot, we're not going to tell you one of the factors. You're going to have to figure them out on your own. So if we look at this one over here, if you understand how factoring works, if you apply a theorem, this PR apostrophe S, please don't take this the wrong way. It doesn't stand for Puerto Ricans. It stands for possible roots, possible rational roots, okay? So you're going to see me use that abbreviation. Possible rational roots, maybe you'll see where they come from. They're plus or minus 1 and plus or minus 11. So they don't tell me any of them, and guess what? I do have to guess and check now. I have a list of 4 roots that might work. So I have to start synthetically dividing. Remember when I said you'll be synthetically dividing 1,000 times? Well, here you go. Where should we start? 1 or -1 or 11 or -11? I like to start at 1. So what are we looking for when we do this division? We're looking for a 0 remainder. Ooh, right off the bat, we got one. So, what are our zeros then? We get one of them right away. What's the first one? 1. Remember, the number in the box, if the remainder is 0, the number in the box is the 0. But in factored form, it would have been x minus 1. Okay, everybody see that? Okay, cool. So then we've got x squared minus 12x plus 11, which factors further into nice, x minus 11, x minus 1, perfect. Good. So then what are our other zeros then? Positive 11 and positive 1. Isn't that weird that the 0 happened twice? It can't happen though. I gave my advanced class a quiz. The 1 0 happened 3 times. Zeros are allowed to repeat. They do repeat sometimes. So that's where we're going to be heading next week. Does anybody have any comments, concerns, questions, short debates, long debates about any of that? If not, what I'd like to do is take one last look at this long division. On the Math Excel, they said use long division. Sometimes you have to use long division, okay? But if you can use synthetic, use synthetic. On the worksheet from yesterday, the one exercise, they said use long division. Let's take a quick look at it. 2x cubed. This is number 12 from the worksheet. They got 2x cubed minus 3x squared. Minus 18x minus 8. Minus 18x minus 8. And they want us to divide that by x minus 4. Yesterday I was using the metaphor about the hot dog shop, or 2 days ago. Remember when you go to the hot dog shop, you can drive all the way out on the bypass, Go past the Walmart exit in Warren. Go past the East Market exit where the most magnificent McDonald's is. Go all the way to 46. Almost rear end somebody because people don't know how to drive out there. Wait in traffic for 48 minutes because there's an accident because somebody else did rear end somebody else. Drive around it, stop in Dunkin' Donuts, wait an hour to make a left-hand turn out of Dunkin' Donuts. Go to the mall, have to park 48,000 miles away. Walk 20 minutes to get into the mall. Get your pretzel. See 8 other people you know that you really didn't want to run into. Go and find out that the shoes that you want are on sale and they don't have your size, but they can order them, but you don't want to because you're there and you want them now. So then you go to the hot dog shop. So anyways, this is kind of like that. X minus 4 into 2x squared. 2x cubed, I mean, minus 3x squared minus 18x minus 8. So you could do all this work if you want. Sometimes you have to know when to not look at certain stuff, right? When you go past the East Market Street exit, you got to say, you know what, I'm not going to think about that magnificent McDonald's because I want to go in there and play the piano, even though they won't let me. You just have to disregard all that other stuff and just kind of block it out. So how many times will I ask myself why? How many times? This is going to be 2x squared and I get 2x cubed. And now I got to think back to that most magnificent McDonald's, okay? So now I got to bring all this stuff back. And I'm multiplying 2x squared by x minus 4, so I get 2x cubed minus 8x squared. And then I got to subtract. And this is the part that people who were trying this on the worksheet, this is the part that they were dropping the ball on. 2x cubed minus 2x cubed, those cancel, and everybody's okay with that. But this first difference here, the first difference, people want to say it's negative 11x squared. I got news for you. It's not. It's negative 3x squared minus 8x squared. So it's plus 8x squared. So it's the difference between negative 3x squared and 8x squared. So it's 5x squared. Okay? It's kind of weird how I can read people's minds sometimes. I'm telepathetic like that. So I bring down the negative 18x. And here we go again. So we get off at the Lowe's X and we say to ourselves, you know, I really need a new steel chainsaw, but I'm going to forget about Lowe's. Lowe's isn't even there. La, 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 la. I'm not going to Lowe's, not going to Sheetz and getting that banana iced coffee. How many times does x go into 5x squared? How many times does x go into 5x squared? I guess it goes in positive 5x times. Good. Okay. So you know what? Maybe I do need to stop at Sheetz because I'm almost out of gas and I'm going to run out of gas waiting in all this traffic. Thanks, non-drivers. So when I multiply here, I get 5x times x, which gives me 5x squared. And 5x times negative 4 gives me negative 20x. And again, I subtract, and I like to have parentheses so I can keep track of stuff. So I have the 5x squareds cancel. Again, everybody's good with that. The next difference isn't negative 28x. What's the next difference? It's 2x. Good, nice. So we get 2x. And one last time, we got to bring down that minus 8. And one last time, we got to say, okay, so here I am. There's Dunkin' Donuts. I see it on the hill. But you got to kind of put it out of your mind. Dunkin' Donuts, you're not there. I spend way too much money at you. Your coffee's addictive. I don't know what they put in it. But I'm not going to go there. Not going to do it. I'm using restraint. I'm not going to Dunkin' Donuts. X goes into 2x how many times? 2. You know what? I've been in line all for this traffic the whole time, and a donut sounds really good right now to get me ready for the hot dog shop. So I am going to go ahead and go to Dunkin' Donuts. So here, what do I get? I get 2x and minus 8. I subtract. What do I get for a remainder here? Double line. Nice. Good. We remembered. Double line, no remainder. And then that's it. We made it to the hot dog shop. So, I'd like to do a split screen of this just to show you that some ways to the hot dog shop are far superior than other ways to the hot dog shop. Don't talk to my wife about driving in Warren. She grew up there, but she and I have a huge disagreement about how to get there, how to get certain places in Warren. So here we go. We got 2, 8, 5, 20, 2, 8, and 0. Oh my gosh, did we just like take a Kawasaki ZX14 to the hot dog shop or what? The problem is when you get there that fast, sometimes wasn't there somebody in a green suit out at Liberty Tax Service waving? Were they wearing glasses or weren't they wearing glasses? What the heck does any of this mean? It means my answer is 2x squared plus 5x plus 2. The Statue of Liberty people at Liberty Tax Service, I'm entertained by them. Them and the people in the puppy suit. If you ever go to Boardman Guitar Center, there's always people in puppy suits out by the one dog place. Well, well, well. I think that wraps up as much about 5.4 as I got to say. Does anyone have any questions, comments, concerns, short debates, long debates about any of it? Well, I'm going to give a shout out to the future Mr. Minnick because he deserves it. I'm going to give a shout out to Mason Butler because Nate loves you and because you haven't seen either of the other videos because the last one, the audio got cut out somehow. I'm going to shout out to my first period class for being patient. I'm going to give a shout out to my second period class. I don't know what for, but just for. I would give a shout out to one person in my fifth period class, but they're probably not there, so that person's not going to get a shout out. And then that's it. Have a great day.